Assalamualaikum warahmatullahi wabarakatuh. Let's continue our class with alcohol classification. Okay, alcohol can be classified into three types, which are primary alcohol, secondary alcohol, and tertiary alcohol. So how do you distinguish between primary, secondary, and tertiary? So for primary alcohol, the hydroxyl group that attached to the carbon, okay, this carbon is considered as a primary carbon because this carbon attached only to one alkyl group. Okay, whereas for secondary alcohol, this hydroxyl group attached to this carbon, and this carbon is considered as a secondary carbon because this carbon attached to two alkyl group. And the tertiary alcohol, when the hydroxyl group attached to tertiary carbon, because this carbon attached to 1, 2 and 3 alkyl group. Okay, and for physical properties of alcohol, alcohol is categorized as a polar compound. Why? Because it has OH group. Okay, OH group is considered as a polar covalent NCO, and alcohol interact with themselves and with other polar compounds by dipole-dipole interaction. Okay, what is a dipole-dipole interaction? Dipole-dipole interaction is the attraction between the positive end of one dipole and the negative end of another. Okay, and then alcohol associated in the liquid state by hydrogen bonding. So it can perform hydrogen bonding, okay, and the strength of hydrogen bonding in alcohol is approximately 2 to 5 kilocalorie per mole, and the hydrogen bonding are considerably weaker than covalent bond. Okay, this is the hydrogen bonding between the O and H from one group of alcohol with another one group of another alcohol. Okay. Okay, let's take a look of the, we call as the solubility. Okay, solubility. So the solubility decrease when the number of the carbon in the structure increase. Okay. Why? Why this become like this? Okay. Let's say this carbon, this part of carbon we call as the hydrophobic part. The OH group we call as hydrophilic part. When the number of the carbon in the hydrophobic part increase, so the solubility of the alcohol will decrease in the water because the water is hydrophilic properties. Okay, this part is hydrophobic. So hydrophobic, it cannot dissolve in the hydrophilic. When this part increase, so the solubility in the water also decrease. So that's why when you see here hexane, you do not have any OH group here. So the solubility in water is insoluble. It can only dissolve in organic solvent, not in the water, because in the water you have OH group. So it can form, we call as the hydrogen bonding with the alcohol. So it can be solubilized in water. If not, it cannot be solubilized in water. So we categorize as insoluble. Okay, if we compare with the boiling point, okay, let's say here, when you have a straight chain alcohol, so here is one propanol and one pentanol. When the number of carbon in the structure increase, for one propanol you have 3 carbon, here you have 5 carbon. So when you compare the boiling point, this boiling point is 97. Here is 138. So when the number of carbon in the structure increase, the value of boiling point also increase. Because why? It takes more energy to break the chain between this carbon and this carbon. Okay, so that's why the boiling point increase. Okay, if we compare one pentanol with one 4-butane diol, you see here the boiling point is 138. But for this compound, the boiling point increased to 230. Why? Because in this structure you have only one OH group. In this structure you have 2 OH group. So when you have a more OH group, there is more tendency to form hydrogen bonding. So we consider the hydrogen bonding is more stronger compared to covalent bond. Okay, when the number of OH group increase in the structure, so means that more hydrogen bonding can be formed. So more energy need to use to break this hydrogen bonding. Finally, the boiling point increase. Okay, that is how you explain when you have this kind of question. Okay, I want you to try to solve this question, this exercise, and please show me the answer in your class notebook for today class. So I want you to list from the lowest to the highest and which alcohol has which boiling point. Okay, so 82.3 is referring for which alcohol. Okay, and then please do not forget to put the IUPAC name for each of these 3 alcohol. Okay, and also this exercise. Arrange this compound in order of increasing solubility in water and boiling point. So you have to answer. One is for solubility in water and another one is for boiling point. Okay. Because alcohol can interact by hydrogen bonding with water, they are more soluble in water than alkane and alkene of comparable molecular weight. Okay, methanol, ethanol and 1-propanol are soluble in water in proportion. Alcohol of higher molecular weight are much less soluble in water because of the increase in the size of hydrocarbon portion. Meaning that the hydrocarbon portion is categorized as hydrophobic part of the molecule. Okay, what's about the property of the acidity? Most alcohol are about the same or slightly weaker acid than water except methanol. And the aqueous solution of alcohol have the same pH as that of pure water. And the acidity depends primarily on the degree of stabilization and solvation of the alkoxide ion. And the negatively charged oxygen of methanol and ethanol are about as accessible as hydroxide ion for solvation. These alcohols are about as acidic as water. As the bulk of the alkyl group increase, the ability of water to solvate the alkoxide ion, the alkoxide decrease. The acidity of the alcohol decrease and the basicity of the alkoxide ion increase. Okay, pKa value for several lower molecular weight of alcohol. You can refer to this table. Okay, later I will explain about the method of preparation. Okay, in next lecture video. Okay.